Okay, so that last approach to solving that set of examples was kind of confusing. Here's a different strategy that might make a little bit more sense. Okay, so we are going to start with our angle. It could be literally any angle in between 0 and 90 degrees. So our angle, when added together with its complement, should add up to 90 degrees. So an angle's measure plus the measure of the complement equal 90. That's what it means for it to be that angle's complement. Two angles are complementary to each other if their sum is 90. They add up to 90. So we can think of it, an angle A and its complement C equal 90. So that means an angle and its supplement added together should equal 180. So if we wanted to solve for an angle's complement, if we wanted to find an angle's complement, that would mean in this equation that we're trying to solve for C. We're trying to isolate C. We want to find the complement. So we would subtract A from both sides. So a complement of an angle is equal to 90 minus the angle. Same thing over here. If we wanted to isolate the supplement, if we were trying to find an angle's supplement, that means we're trying to solve for S. So we need to isolate the S. We need to get rid of the A. We're going to subtract A from both sides. And so a supplement of an angle is 180 minus the angle. So this could come in handy when I give you something like the angle isn't just A. What if the angle was 3x minus 10? We wanted to find the complement and the supplement of that angle, 3x minus 10. Same equation that we want to set up. The same two equations. We want to say our angle plus its complement should equal 90. Our angle plus its supplement should equal 180. And so instead of saying A, I'm going to substitute this expression, 3x minus 10, into the equation in place of my angle. So instead of A for angle, I'm going to put 3x minus 10, because that's what my angle is, plus my complement equals 90. So if I'm trying to solve for the complement, if I'm trying to isolate C, I need to move over my 3x and I need to move over my negative 10. So to move my negative 10 to the other side, I'm going to add 10 to both sides of my equation to get 3x plus C equals 100. And then my last step to isolate C is I'm going to subtract 3x from both sides. So the complement of 3x minus 10 is 100 minus 3x. We can double check that because remember, an angle plus its complement should equal 90. Our angle is 3x minus 10. The complement that we just found is 100 minus 3x. And if we add our angle and our complement together, it should equal 90. Well, positive 3x and negative 3x cancel each other out. Negative 10 and 100 give us 90, which is exactly what we want. So this angle, 3x minus 10, and this complement, 100 minus 3x, added together will give us 90. Okay, so if we wanted to find the supplement of 3x minus 10, I'm going to substitute this expression, 3x minus 10, in for my angle into my equation. And again, I want to isolate the S. I want to find the supplement, so I need to get the S by itself. So I need to move over the 3x, and I need to move over the negative 10. I'm going to add 10 to both sides to get 190. And then I'm going to subtract the 3x from both sides. And so my supplement is equal to 190 minus 3x. That's the supplement of this angle. And we can double check it because 3x minus 10 plus 190 minus 3x should add up to 180. 3x and negative 3x cancel each other out, and negative 10 and 190 add together to equal 180, which is exactly what we want them to equal to. Cha-ching! This indeed is the supplement of our angle. Okay, what about our word problem? Can we apply the same strategy to our word problem? Yes. An angle supplement, so S, is equals 60 less than. That means we're going to subtract 60 from something. 60 less than what? 3 times its complement. 3 times C. The supplement is 60 less than 3 times the complement. Then remember, we have two equations. Our angle plus our complement equal 90, and our angle plus our supplement equal 180. Okay, so we have 3 equations. We have a system of equations. We have 3 variables. So that's a little tricky. So what I want to do is I want to do some rearranging and some substitution so I can plug stuff in and end up with one equation that only has one variable. So hopefully you remember this from algebra, but it's okay if you don't. So the first thing that jumps out at me, the first thing that I notice is that this S is already isolated. So I see an S all by itself here, and I see an S all by itself here. And so what that means is since S is equal to 3C minus 60, I can plug all of this stuff in for S into this equation. Wherever I see S, I can substitute it with 3C minus 60. Okay, then I see an A in the equation. Well, I see an A right here. So what if I isolated that A by moving this C over? A equals 90 minus the complement. So now I can substitute 90 minus the complement in for A. So instead of A, I'll do 90 minus C. Instead of S, I'll do 3C minus 60 equal 180. Now I have one equation that only has one variable. So now I'll combine my terms. 3C and negative C give me 2C. 90 minus 60 give me 30 equals 180. Then I subtract 30 from both sides. 2C equals 150. Divide off the 2. And so C is equal to 75. So that means the measure of the complement is 75. Well, if we think about over here, our angle is 90 minus its complement. Our angle equals 90 minus 75. That means our angle is 15 degrees, has a measure of 15 degrees. And then if you know the angle, then you can find the supplement, because remember the angle and its supplement equal 180. So if our angle is 15, then our supplement's just 180 minus 15, and our supplement is 165 degrees. The measure of the supplement is 165 degrees. So in this problem, our angle has a measure of 15 degrees. The measure of the complement of that angle is 75 degrees because 15 plus 75 equals 90. And the measure of the supplement of that angle is 165 because 15 plus 165 equals 180.